HC109S2 primary current injection tester is an instrument used to test and calibrate power system protection equipment, such as protection relays, circuit breakers, and switchgear. It simulates actual short circuit or overload conditions by injecting high current into the primary side, i.e., high voltage side, of the power equipment, thereby testing and verifying the responsiveness and accuracy of the protection equipment under high current conditions. The main purpose of this tester is to verify whether the protection equipment can respond in time and protect the power equipment and lines from damage when a fault occurs in the power system. It is usually used in the maintenance and testing of power systems such as substations, power companies, and power plants. Main functions and effects. Protection equipment testing and calibration. HC109S2 tester tests the action and response time of protection equipment by simulating fault currents, such as short circuit current, overload current, etc. It can be used for the calibration of equipment such as relays, circuit breakers, overcurrent protection devices, etc., to ensure that these devices can trigger protection actions in time when actual faults occur. Verify the action characteristics of the protection device. By providing the set current and time, the tester checks the action characteristics of the protection device to ensure that the device can act in time under the set threshold and meet the design requirements. Improve system reliability and safety. Performing the main current injection test regularly helps to ensure that the performance of the protection device does not change under the influence of long-term operation, aging, or other factors, and avoid power accidents caused by protection device failure. On-site commissioning and maintenance. The main current injection tester is usually designed to be easy to carry and suitable for on-site commissioning and maintenance work to ensure that the actual operating status of the equipment meets the design requirements. Main features. Simulate high current fault conditions. The tester can inject high current on the main side, high voltage side, of the power equipment to simulate fault conditions, thereby testing the responsibility of the protection device under fault conditions. Typical current ranges can reach hundreds of amperes to thousands of amperes. Multiple test modes. The main current injection tester usually supports multiple test modes, such as overcurrent protection, circuit breaker tripping, relay action, and other different types of tests. Protection device response test. It can simulate different types of electrical faults, such as short circuit, ground fault, overload, etc., to check the response time and action accuracy of protection devices, such as relays and circuit breakers. Adjustable current and time settings. The tester can adjust the amplitude and duration of the injected current, which is convenient for flexible setting and testing according to the requirements of different protection devices. Real-time data monitoring and recording. The main current injection tester is usually equipped with real-time data display function, which can display important parameters such as current, voltage, time during the test, and support data recording and report generation. High-precision measurement. Provide high-precision current and voltage measurement to ensure the accuracy and reliability of test results. Working principle. The main current injection tester injects current into the main side, usually the high voltage side, of the power equipment through an internal high-power power supply. During the test, the instrument gradually adjusts the amplitude of the injected current and monitors the response of the device under test in real time. Usually, the device responds through the set protection contacts or devices, such as disconnecting the current, triggering an alarm, etc. The tester records the response of the protection device and evaluates whether it meets the preset protection standards. The core of the test is to simulate actual fault conditions. The injected current usually reaches hundreds or thousands of amperes, which is much larger than the normal operating current and close to the level of the fault current. During the test, the instrument monitors the equipment's action time, action threshold, and other parameters to evaluate whether it meets the protection requirements.